representation. So therefore, we use hexadecimal representation. And here, the values that are used are 0 to 9, plus after that, we use A to F. So 16, base 16 means the values, there should be 15 values, right? So 0 to 9 and A to F are used for base 16. So like for example, suppose you want to show what is 255 in hexadecimal. How do we do that? So we take 255 and start dividing it by 16. So we take 255. Let's divide it by 16. So 16 will go how many times? 16 ones are 16. Then we have 95, 16. 5s are 18, right? 16 5s are 80. So 95 minus 80 is 15. So basically we have 15, 15. That is our representation, because now the value is less than 16, we cannot divide further. So 255 is basically 15, 15. But in hexadecimal system, from 0 to 9, we represent all the 9 numbers. After that, 10 is represented by A, 11 by B. Like that, if you go on, C is 12, D is 13, E is 14, and F is 15. So 15, 15 means it is FF. FF stands for 255. So that is what is a hexadecimal representation of 255. And it uses 4 binary digits, which is called as a nibble. So it uses 4 binary digits. And now, if we want to convert this into binary from hexadecimal, 4 binary digits. So F is what? 15. 15 is what in binary? It is, if you just look at 15 and divide it by 2, then you will get 2. 7s are 14, and then you have a 1 remainder. 2 goes 3 times, then you have a 1 remainder. 2 goes 1 time, and again 1 remainder. So you have 1, 1, 1, 1. So F means 1, 1, 1, 1 in binary. Another F is there, again 1, 1, 1, 1 in binary. So 255 in binary is represented by 1, 1, 1, 1, 1, 1, 1, 1. So that is how we convert from decimal to hexadecimal, further to binary. So when we are converting to binary, you can see each hex digit represents 4 binary digits. So over here, FF means first F is 1111, second F is 1111. So it becomes simpler for converting from hex to binary. Now, how do you get the value of, let's say, 16 in hexadecimal? So again, what we need to do is take 16. Let's get it here. We'll take 16. And we divide it by 16 itself, because it's a hexadecimal system. So 16 will go 1 time and the remainder is 0. So what we are getting over here, 1, 0. So 16 is represented as 1, 0 in hexadecimal. Now, how to convert it into binary? Now we have 2 digits in hexadecimal. Each digit should be converted into binary into a nibble. That means 4 binary digits. So over here, 1, how do we represent? We represent 1 as 0, 0, 0, 1 in binary. We are just adding some zeros at the back because we need to show it in a 4 binary digit, in a nibble. Then the second digit is 0. 0 is just given by 4 zeros. That is 0, 0, 0, 0. So this is one nibble. This is the second nibble. So for the first hexadecimal digit, we have used one nibble. For the second hexadecimal digit, we have used another nibble. So this is the binary representation of 16. So if you just look at the powers or place values of binary representation, the last one is 2 to the power of 0. That means it is 1. Then the next one is 2 to the power of 1. That means it is 2. Then we place value is 2 to the power of 2, which is 4. Then 2 to the power of 3, which is 8. 2 to the power of 4, which is 16. 2 to the power of 5, which is 32. So these are the place values. 2 to the power of 6, which is 64. And 2 to the power of 7, which is 128. So over here you can see there's one only for 2 to the power of 4, which is 16. So that is the binary representation. So that's how you get the binary representation from the hex. It makes it simpler for conversion from binary to hex. So now let's look at some problems. Okay. So then let's see how to decimal fractions, how do we represent in binary? Now let's see 0.625, how to convert it into binary. So the method over here is just multiplying by 2 now. For the integer part, what we were doing is dividing by 2. For the decimal part, we have to multiply by 2. Like for example, we are taking 0.625. So 0.625, we start multiplying by 2. And then we will write the, when we multiply, the result what we get, we have to write the integer part only. So like for example, let's take this. 0.625 into 2. We have to do. Into 2 means we will get, how much we will get? We will get 1.25, right? 2 5s are 10, 2 5 0, let's say. 2 5s are 10, 0. 2 6 are, 2 2s are 4 plus 1, 5. 2 6 are 12. And we have 3 decimal digits, so 1, 2, 3. We have put a point over here. So 1.250. In this, we have got integer part as 1. That is what we have to write over here. The next thing, what part is there in the decimal over here? 0.250. So 0.250 into 2 again we have to do. And then we will get 0.250 into 2 is 0.500. And here, what is the integer part we have got? We've got a 0. So we write 0 over here. Now 0.5 into 2 again we have to do. So we have to keep doing till we get no further decimal part. So if you multiply 0.5 into 2, you will get 1, right? 100. Now the integer part over here is 1. So we have to write that as 1. So we have got, further we have got zeros over here in the decimal part. So there is no need to multiply with 2 again. So what is the decimal part now? 0.625 can be represented as 0. Again, we go in this order, 101. So 101. So that is the decimal representation of 0.625. So 0.625 in, binary representation. Binary is 0.101. Hope that is clear. Let's look at what is 0.75. Can you find the answer to that? 0.75, how do you convert it into binary? Give me the answer to that. 0.75 into binary. So you just keep multiplying by 2 until you get no further decimal part. Yes, students, try this. What is 0.75 in binary representation? Give me the answers. You can share in the chat. Yes, are you all there? Pooja, Aditya, Akash, Anushri, try it out. You can see the example and try it out. Aditya, what question marks? Okay. See the integer part, when you multiply by 2, whatever integer part you get, that is what you should write it. Okay. So that will form the decimal representation, the binary representation for the decimal part of your question. So 0.625, when you multiply by 2, you will get 1.25. So we write only the 1 over here. The decimal part, again we take it and multiply by 2. So 0.5 you will get. So over here the integer part of this is 0. So that's what we write. Again 0.5 into 2, you will get 1. So now, after the decimal point, we don't have any number. We have a 0, so we no need to continue. But the integer part is what you have to write it over here. And this is what is a binary representation. 0.101 becomes a binary representation for 0.625. So similarly, if we do 0.75, so 0.75, what happens? Let's do that. So 0.75 into 2, we will get 1.5. So since we've got 1.5, what is the integer part of it? It is 1. So we write down this 1. Then we have a decimal part over here, 0.5. That 0.5 we will take and multiply by 2 again. So when we multiply, we will get 0.5 into 2 is 1.0. So again over here, integer part we have got as 1. So we get 1, 1. Now decimal part is 0 now. So no need to further multiply by 2. So what is the representation of 0.75? We've got 1, 1. So that is what we are going to write. Decimal representation of 0.75 is 1, 1. Yeah, I mean the decimal 0.75 in binary is 1, 1. Okay. And suppose you have to show it in, suppose your options are in 4 digits, that is in a nibble, then you can add zeros to the right side. If it's a decimal, you can add zeros to the right side. So the representation becomes 1100, right? So yeah, very good. You have got it correct, but you have to put the decimal point 0.11, Aditya. That is the answer. If you just put 11, the value of 11 in binary, if you convert to decimal, it will become 3, isn't it? So you have to put a 0, 0.11. Pooja, you're correct. So next is, what is this number in binary? So can you convert this into binary? You have to take the integer part separately and decimal part separately and convert it into binary. So integer part, I think that part you can do it easily. So when we convert this integer part, in this there are 2 parts, right? Let's take the integer part, that is this one, 1101. So when we are taking 1101, how do we convert it? We use the place values. So what is the place value of this? 2 to the power of 0, that is 1. Then place value of the second part, that is the second digit, is 2 to the power of 1, which is 2. Then this is 2 to the power of 3, which is 8. And this is 2 to the power of 4, which is 16. So now we have to see. There's a 1 over here, that means 16, plus there's 1 over here, that is in placeholder of 8, that is plus 8, plus for this there is 0, so 0 into 2 is 0 only. So then there is 1 over here, so 1 into 1 is 1. So the value over here is 16 plus 8, 24, plus 1, 25. So the integer part is 25. We've got the integer part in decimals. Then the other part. What is the other part? The decimal part. We have the decimal part over here is 1100. So let's write that down, 0.1100. Now here 1100, how to convert it into decimal is, we take the placeholder value after this point as 1 by 2. This is the placeholder for this is 1 by 2. Then there is 1 by 8. This one is 1 by 16. Like this it will go on. Then 1 by 32. So over here, what is 1 by 2? 1 by 2 means 0.5. 1 by 8 means, sorry, this is 1 by 4, 1 by 8, 1 by 60, and 1 by 32, and so on. So 0.5, 0.25, 0.125, 0.0625, 0.03125. Like this, it will go on. So over here, we have only for the one for the first two places after the decimal point. That means 0.25, we have 0.5 plus 0.25. So this is 0.5 plus 0.25. So what is that? 0.75. So now if we convert this binary number into decimal, the value will be 25.75. That is the answer. Okay, so placeholders over here, if you see, it will take the values of 0.5, 0.25, 0.125, 0.0625, 0.03125, like that it will go. That means half, 1 by 4, 1 by 8, 1 by 16, 1 by 32, like that. So binary, in binary, whatever is there after the point, you have to convert it like this. Hope that is clear. Let's look at some more questions. So ASCII to decimal, now we have A as 65 and the hexadecimal value of 65 is 41. We saw that. How do we get that? Divide 65 by 16 and you will get it. So if we do that over here, ASCII to hexadecimal conversion. So we have 65. 65 divided by 16. 16 will go 4 times. Remainder is 1. 16 4s are 64. So 65 minus 64 is 1. So 4 1. So 65 is represented as 41 in hexadecimal. 66 is the code, ASCII code for the letter capital B, and that is 42 in hexadecimal. Now suppose you get a string ABC. How is that represented in hexadecimal? ABC. ABC is A is 41, B is 42, C is 43 in hexadecimal. So if we have something like this, if the question is there like this, what is 41, 42, 43 in hexadecimal? Convert that to ASCII. Then the answer will be 41 means A, 42 means B, 43 means C. That means in ASCII, 41 is nothing but 65. That is A. 42 is 66. That is B. 43 is 67, which is C. So this is how to convert. Now, hexadecimal to binary conversion, let's say 1F. How to convert it into binary? Now, each digit in hexadecimal should be converted into a 4-digit nibble in binary. So 1 means 0, 0, 0, 1. F means 1, 1, 1, 1. F is 15. So 15 is 1, 1, 1, 1 in binary. So therefore we get this value. Similarly, A3 in hexadecimal. A means what? After 9 comes A in hexadecimal. That means 10 is A in hexadecimal. How do we represent 10 in binary? 10, if you see, if you do that, 10, if you do the division, so you get 5, 0, 2 twos are 4, 1, 2, 0, 1. So you get 1, 1, 0. That is what you get. So since we have to use a nibble, what we do is we write 1, 1, 0. 0, 1, 1, 0. Then we have a 3. 3 is written as 0, 0, 1, 1. So that is 3. That means if you say 3, 2 will go how many times? 2 ones, 2 ones are 2, and then there is a 0 here. So 1, 0, 1, 0, 1, 0. That is the representation of this. 1, 0, 1, 0. And then 3 is 2 ones are 2, remainder is 1. So we have 1, 1. But we have to show it in a nibble. So 0, 0, 1, 1 we have to write. So that is the binary representation for A3. That is how we have to convert to binary from hexadecimal. Let's okay. Now, which encoding standard is most commonly used to represent text in computers and other devices that use text? So let's answer this. Give me the answer to this. Unicode, ASCII, EBCDIC, ISO. So all these are different encoding standards. So most common used is for text is ASCII, right? ASCII. ASCII is the most commonly used. Yes, Praveen, you're right. Next, if you see what the others represent, ASCII uses 128 characters and it's used for basic text processing. Unicode is called as universal text representation. So it has 16-bit, 32-bit, 8-bit representations, universal text representations, and it almost can, it has a code for everything, including all the special characters, everything. So if you see how many characters are there, 143,000 plus characters are there in Unicode. So it is an advanced uh, encoding standard compared to ASCII. But still ASCII was formed earlier and it is still prevalent in most of the systems. Then EBCDIC is encoding standard for IBM mainframe. So now it is not normally used. Then we have ISO 8859-1, which is for Western European text processing. Like we have some special representation for, say, French language characters and all that. So for that, this ISO 8859-1 encoding standard is used. Then we have a bit of addition, subtraction, multiplication, and division. So addition in binary is very simple. So suppose you have to do 1011 plus 1101. What is this? 11 plus 13. Question will be add 11 plus 13. And the result they will ask you to give in binary. They'll give some options. How to do that? So 11 in binary, first you convert 11 to binary. So 11 is given by 1011. How to do that, you know already. Divide 11 by 2. Right? So we keep dividing and we will get 11 as 1011. Similarly 13. If we divide 13, how much do we get? If we divide by 2, 2 6 are 12 and remainder is 1. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. So 1 1 0 1. So that is 1101 over here. And 11 is 1011. If we add this 1 plus 1, 1 plus 1 we get 2. But 2 in binary is written as 10, right? 10 means 2. So we write a 0 and then carry over this 1 over here. Then we have 1 plus 1 over here. So 1 plus 1 is again 2. And then there is a 0 over here. So 1 plus 1 is 2. 2 again is written as 10. So we write this 0 and carry over 1 over here. So again we have 1 plus 1, which is 2. So we write the 0 and carry over the 1. Now we have 1 plus 1 plus 1. So 1 plus 1 is 2, which is 10. 10 plus 1. 10 plus 1 means it is 11. So we write the 11 over here. So this is the answer. If you convert this into decimal, what you will get? The place value of this is 1, 2, 4, 8, 16. So 16 plus 8 is 24, right? So 16 plus 8 is 24 and all others are zeros. So the value of this is 24. If you convert it into decimal, it is 24. So you can see 11 plus 13 is 24. So that's the correct answer what we've got over here. So that is binary addition. Subtraction we can do in two methods. One is by using the borrow method. The other is by using the 2's complement. So when we do the borrow method, 1011 is 11 again, and 5 is represented as 0101. So 5, if you just keep dividing the same pattern, you will get the value 0101. So I suppose you want to subtract 11 minus 5. That is a question. You want to do 11 minus 5. So 1 minus 1 is 0. 1 minus 0 is 1. Here there is 0. So you have to borrow. So you have to borrow from here. So when we borrow from here, you are borrowing it over here and giving it to this. So it becomes 1, 1, 0. 1, 0 means 2. 2 minus 1 is 1. So you get a 1 over here. And here, since we have borrowed, this value will be 0. The value over there is 0. So this is by the borrow method. So this is what we can do. There is a then we have multiplication and division. If you have 5 minutes, we can cover this multiplication and division. If at all it's okay, we'll do it. Otherwise, we will stop here. Yes, students, shall we do the multiplication and division part or shall we stop here? I think it's time for lunch. We will stop here and we will have a discussion in the group in case if it's okay for everyone. We can have another session. We will announce the time and date for one more session, maybe another 1 hour. We can have it. We will announce the time and date looking at your timetable, exam timetable. We can have one more session where we can complete multiplication, division, and the remaining part. Like, we can also look at 2's complement arithmetic and floating point and operating systems. So these things we can cover in another 1 hour. So we will have a discussion in the WhatsApp group. Hope all of you are there in the WhatsApp group. And if it's okay for all, we can have one more hour session on another day before your exam. All right. Thank you so much for joining. And hope this was gave you some inputs on how to prepare for computer awareness. So these are the kind of questions that will be coming. Wishing you all the very best. And we'll see if we can have one more session. Thank you so much.
Thank you, ma'am.
Welcome.
Yes, I hope all our students have learned many things about the computer awareness. Dear aspirants, we'll be sharing all the material on the WhatsApp group by the end of the day. So you can have, you can prepare for your exam. All the very best for your exams. So take care and we are signing off. Thank you, ma'am.
Thank you.